Imagine a completely blank terminal screen, right? And an AI agent just gets to work. No starting code, no pre-built libraries, absolutely no human handholding.
Yeah, and you fast forward a few hours, and entirely on its own, it has built a highly complex Rust text-to-speech engine from the ground up.
Literally from scratch. We are talking about constructing the neural model, writing the SIMD kernels, which, requires intense hardware-level optimization that even seasoned developers struggle with.
Oh, totally. It's notoriously difficult.
Exactly. And it builds a fully functional browser demo.
Yeah.
Then, without even being prompted, it runs its own generated audio output through a separate speech recognizer just to verify that its code matches the Python reference model perfectly.
It really forces a total recalibration of what an AI tool actually is. I mean, we are far past the point of just auto-completing a line of Python.
Right.
We are looking at a system capable of end-to-end architecture design, execution, and critical self-verification.
Coming to you, live from the turning point of history at Beskar.
Welcome to AI Deep Dive with Beskar. This is episode News of the Week. I'm Adam, and sitting across from me is our resident expert, Amy.
Hey, everyone. Great to be here.
So if you rely on this kind of rapid-fire technical breakdown to stay informed, do us a huge favor and hit that subscribe button. It really tells our team that you want more of this specific news-focused content.
Yeah, and after a string of really hyper-focused deep dives over the past few weeks, today we are zooming out for a landscape overview.
A much-needed one, honestly.
Seriously, because we are breaking down a massive release that just dropped today, April 16th, 2026. Anthropic has officially launched Claude Opus 4.7.
It's huge. But before we get into the weeds here, I do want to give a quick disclaimer right out of the gate. Because this dropped mere hours ago, our analysis today is based strictly on Anthropic's official technical blog posts and the published reports from their early access beta testers.
Yeah, we haven't actually had the runway to benchmark Opus 4.7 internally ourselves yet.
Right. But the data coming out from these testing partners is simply too significant to wait on. And to really set the stage for why this 4.7 drop is so monumental, we actually need to look at something that happened just before this announcement.
Oh, you're talking about the whole Sentry workflow shift.
Yes. David Kramer's tweet. So David posted about Sentry doing its bit by notifying AI agents directly when an error occurs.
Which is just a massive paradigm shift in how we handle production bugs.
It really is. I mean, usually Sentry catches an error and immediately pings a human developer on Slack or PagerDuty, right?
Yeah, and completely ruins their weekend.
Exactly. But now, Sentry is routing that error notification straight to an autonomous agent. The agent gets the ping, reads the error stack trace, clones the repo into a sandbox, and literally just starts fixing the bug while the human is asleep.
It's incredible.
Yeah.
And even though that Sentry workflow was highlighted just before the Opus 4.7 announcement, it perfectly encapsulates our core editorial view today.
Right, which is that the ecosystem is rapidly moving toward completely autonomous systems. Human intervention is basically just required for review and rework now.
Exactly. And Opus 4.7 is the engine that is going to power that exact autonomous future. So let's talk about the baseline specifications, because the mechanics here are fascinating.
Yeah, let's look under the hood. Opus 4.7 is live today across all the standard enterprise channels. So the Anthropic API, Amazon Bedrock, Google Vertex AI, and Microsoft Foundry.
And the raw pricing remains flat, which I know is a huge relief for enterprise budgets.
Oh, definitely. $5 per million input tokens and $25 per million output tokens. But they've introduced a brand new effort parameter. They're calling it X-high, like extra high.
Right. It slots right between the standard high and max compute settings.
Yeah.
And this X-high parameter is critical because it gives developers much finer control over the compute-to-reasoning ratio.
But there is a catch, right? Developers need to monitor their dashboards really closely because of the new tokenizer.
Yes, the tokenizer is completely rebuilt.
And I actually want to pause and explain the mechanism there because, the word tokenizer gets thrown around a lot. But tokenizer isn't just a word counter. It's the underlying algorithm that chops up human language and raw code into subword pieces, the numeric tokens that the neural network can actually process.
Exactly. And if they rebuilt it, people are probably wondering how that impacts their wallet.
Yeah, how does it?
Well, the new tokenizer maps inputs to roughly 1.0 to 1.35 times more tokens than the previous version. So essentially, it's slicing the data into smaller, more granular pieces.
Which allows the model to process nuanced syntax more accurately, I assume.
Right.
Yeah.
But it means a prompt that cost you 1,000 tokens yesterday might cost you like 1,300 tokens today. And when you combine that larger token footprint with the new X-high setting, where the model spends a lot more time generating internal chain of thought tokens before answering count, you will absolutely burn through more output tokens per request.
Okay, but Anthropic is claiming that despite the higher token burn per query, the net efficiency is actually better. And I kind of struggle with that math.
How so?
Well, it sounds like they're just selling us a more expensive compute cycle. Like, I compare the X high effort level to locking a senior developer in a room with a double espresso. They burn way more resources, but they think deeply. How does spending more tokens on a single prompt actually save me money?
I totally get that. But it comes down to the mechanism of loop resistance and error recovery. Older models suffer from this really high variance failure mode.
What do you mean?
Well, if an older model hits a terminal error in its code, it often lacks the internal state evaluation to recognize why it failed. So it just gets stuck in an infinite loop, endlessly rewriting the exact same broken function.
Oh, right. Racking up massive API bills with literally zero progress.
Exactly. Kazoo, the CTO at Genspark, actually analyzed their super agent data on this. He found that a model looping indefinitely on even a tiny fraction of queries wastes an incredible amount of compute.
So Opus 4.7 breaks that cycle.
It does. It utilizes a much stronger internal self-reflection mechanism. When an execution path fails, the XI reasoning allows the model to analyze the stack trace, recognize the dead end, and just gracefully pivot to an entirely new architectural strategy.
Ah, okay. So it gets the right answer with fewer round trips.
Yes. You pay a bit more upfront for the deep reasoning, but you eliminate the wasted compute from those massive infinite retry loops.
That makes a ton of sense. It's basically the difference between a junior developer guessing and checking the same Stack Overflow fix 20 times versus a senior developer stepping back, reading the error log, and realizing, oh, we need a different framework entirely.
That's a perfect analogy.
So speaking of developers, let's look at how this model is actually behaving inside integrated development environments. Because this is where the rubber meets the road.
Yeah, and the benchmark data coming from Cursor is particularly revealing here. Michael Truel, Cursor's CEO, reported that Opus 4.7 clears 70% on Cursor Bench.
70%. Wow.
Yeah, and for context, Opus 4.6 was sitting at 58%.
I want to define what Cursor Bench is for a second, so we don't just gloss over those numbers. Cursor Bench doesn't test an AI's ability to write a simple script in a vacuum, right?
No, not at all.
It tests the AI's ability to navigate massive multi-file enterprise code bases. It asks the model to find a deeply buried bug, understand the dependencies, and implement a fix across multiple files without breaking anything else.
Right, which is incredibly difficult.
So jumping from 58% to 70% on a hard benchmark, like that isn't just a minor update. It's a literal phase change in capability.
It really is. Truel attributed that leap directly to the model's new creative reasoning. And we're seeing that reasoning manifest before the coding even begins. Like, Joe Haddad at Vercel observed Opus 4.7 doing mathematical proofs on systems code prior to execution.
Wait, systems code, like the foundational low-level infrastructure of an application?
Exactly. The fact that the model is performing formal mathematical verification of its logic before it even commits to a path shows a level of planning we just haven't seen before.
That is wild. And I saw that Boris actually had some great suggestions on how developers can best use this new capability, especially inside tools like Cursor.
Oh yeah, Boris's breakdown was super insightful.
What were his main takeaways?
Well, his biggest suggestion was to stop using the model like a basic autocomplete tool. He said, if you're dealing with a complex multi-file refactoring job, you need to explicitly toggle that X-high reasoning mode and give the model full autonomy to map out the architecture first.
Right. Let it do the proofs and planning before you force it to write syntax.
Exactly. He also mentioned that you have to be ready for the model to actually push back on you.
Yes, which connects perfectly to what Caitlin Colgrove over at Hex was saying. She highlighted another mechanism that I find just fascinating. She noted that Opus 4.7 actively resists dissonant data traps.
Oh, this is such a crucial upgrade.
It really is, because mechanically, older LLMs are essentially people pleasers. Their architecture is literally optimized to predict the most statistically likely next token. So if you feed an older model conflicting data or like a logically flawed premise, it will often hallucinate a plausible sounding but entirely fake answer just to fulfill the prompt.
Right, because the older architecture prioritizes the completion of the prompt over the factual integrity of the premise. But Opus 4.7 has a much higher threshold for constraint checking.
It evaluates the provided data against the logical demands of your prompt, and if there's a discrepancy, it just halts.
It correctly reports when data is missing, rather than fabricating a bridge over the gap. Coldgrove actually pointed out that running a low-effort prompt on 4.7 yields roughly the same robustness as a medium-effort run on the older 4.6 model.
That's crazy. And Mikhail Katasta, the president of Replit, touched on this exact behavioral change, too. He noted the obvious cost-to-quality improvements, but he really emphasized how Opus 4.7 pushes back during technical discussions.
Yeah, that pushback is a huge theme.
Right, like we are conditioned to expect AI to act as this sycophantic co-pilot. You paste in terrible code, and it cheerfully optimizes your terrible code.
And tells you what a great job you're doing.
Exactly. Having a model that halts execution to critique your underlying architecture feels less like using a tool and more like arguing with a highly opinionated coworker who thinks your code is messy.
I mean, Igor Ostrovsky, the CTO at Anthropic, explicitly highlighted this during the launch. The model is tuned to bring an independent perspective. It's designed to challenge the user's assumptions.
And that shift from a passive autocomplete tool to an opinionated, independent entity that really bridges us to the core editorial view we need to unpack today.
Right, because this is where the entire ecosystem is pivoting.
Like we said earlier with the Sentry agents, the industry is moving at breakneck speed toward completely autonomous systems. We are rapidly approaching a reality where the human engineer's primary role is not execution, but review, rework, and orchestration.
The era of the digital co-pilot is giving way to the era of the autonomous agent. If we return to the CEO of Factory Droids, Leo Chorokov, his feedback perfectly encapsulates this.
What did he say?
He noted that the missing link for enterprise teams hasn't actually been the intelligence of the AI, but its follow-through. Older models would write a brilliant snippet of code, but the humans still had to manually integrate it, test it, and deploy it.
Right, a lot of manual handholding.
Exactly. But Opus 4.7 carries the work all the way through the finish line.
Yeah, Scott Wu over at Devon echoed the exact same operational shift. He stated that 4.7 takes long-horizon autonomy to a completely new level by working coherently for hours.
Hours.
Just think about the mechanical complexity of an AI working for hours. It has to manage its own context window. It has to maintain a ledger of actions taken, tests run, and errors encountered so it doesn't just lose the plot halfway through the day.
And Anthropic recognizes this shift, and they're building the UI infrastructure to support it. Inside Claude Code, they just introduced a new / command called /ultra-review.
/ultra-review, what does that do?
It isn't a coding prompt at all. It triggers a dedicated review session where the model assumes the persona of a meticulous senior auditor actively hunting for edge case bugs and design flaws in the codebase.
That is so useful.
Yeah, and they also expanded auto mode for Max users, which permits Claude to make compounding decisions on the user's behalf with far fewer permission interruptions.
So I want to pose a question directly to you, the listener. Picture your daily workflow right now. If you can kick off a prompt on Friday afternoon and Opus 4.7 autonomously spins up a neural model, optimizes the hardware kernels, and runs integration tests for 6 hours straight while you're offline, are we transitioning from being the creators of software to simply being the editors and reviewers?
It's a profound shift.
It is. What does it actually mean for your day-to-day routine when your primary output shifts from typing syntax to approving pull requests generated by a machine?
Well, Jeff Wang, another beta testing CEO, framed this identity shift perfectly. He argued that engineers are moving from a one-to-one relationship with their tools to managing massive fleets of agents in parallel.
Which is a totally different skill set.
Completely. The premium skill in knowledge work is no longer rote memorization of syntax. The premium skill is orchestration. It's the ability to coordinate, direct, and verify the outputs of multiple autonomous agents executing simultaneous long-horizon tasks.
But true autonomy has a hard physical limit, doesn't it?
What do you mean?
Well, if we are trusting these agents to run for hours, building front-end applications or debugging servers, they eventually hit a wall if they can't actually perceive the environment they're manipulating. Like, a human worker can look at a screen and immediately see if a CSS button is misaligned or overlapping some text. How does an autonomous agent handle the visual reality of the software it builds?
That is a great point, and it requires a massive upgrade in multimodal capabilities. which is why Opus 4.7 ships with a heavily revamped vision architecture.
The real.
Yeah. It can now process high-resolution image inputs up to 2,576 pixels on the long edge.
Which translates to roughly 3.75 megapixels of visual fidelity.
Exactly. It's more than 3 times the detail capacity of the prior Claude models.
But I have to ask, why does a language model need almost 4 megapixels of vision? Like, does it really need to see the crisp edges of a cat photo to write code?
Well, it's not about photography at all. It's about dense data parsing. Take XBOW, for example. They're a company specializing in autonomous penetration testing.
Okay.
In cybersecurity, an agent needs to read incredibly dense server logs, intricate network topology graphs, and raw terminal outputs. At lower resolutions, an AI's vision blurs characters, so an L looks like a 1 or a capital O looks like a 0.
Oh, and that single visual hallucination causes the agent to fail the entire task.
Exactly. But XBOW reported that their visual acuity benchmark jumped from 54.5% on Opus 4.6 to an astonishing 98.5% on 4.7. The high resolution literally allows the agent to read the terminal perfectly.
That is incredible. And AJ Orbach, who runs a UI/UX company, provided another really great practical example of this vision upgrade. He noted that Opus 4.7 is now his default daily driver for building complex, data-rich user interfaces.
Well, I bet the vision helps a lot there.
Massively. He specifically mentioned that the model's design taste is genuinely surprising, to the point where it makes layout choices that he comfortably ships straight to production. The agent can visually evaluate his own front-end code and adjust the padding and typography before the human ever even sees it.
And that visual capability is paired with a much more robust memory system, too, because long horizon autonomy requires continuity.
Right. It can't just forget everything every 20 minutes.
Exactly. Opus 4.7 utilizes a file system-based memory architecture. Instead of just relying on the immediate fleeting context window, it can save important architectural decisions, design constraints, or past debugging steps to a persistent file system.
Oh, wow. So if it builds the UI on Tuesday and you ask it to expand the feature on Thursday, it just pulls those constraints from memory without requiring you to re-upload the entire project brief.
Exactly. It has continuity.
Okay, I have to play the skeptic here for a minute. Giving an autonomous software agent 3.75 megapixels of razor-sharp vision, file system memory across multiple days, and the capability to execute complex scripts for hours without human intervention, I mean, that sounds like an absolute security nightmare.
It's definitely a concern.
Like, if this agent is running autonomously on my machine while I'm in a meeting, what is stopping it from visually parsing my private emails or executing a malicious payload it found online?
That is easily the most pressing structural question in AI right now, and Anthropic's approach here is highly calculated. This ties directly into Project Glasswing, which they teased last week.
Right, the security initiative.
Yeah. Opus 4.7 is incredibly powerful, but it is actually operating as a tightly controlled testing environment for their upcoming, heavily restricted Mythos Preview model.
Now, the Mythos class is the tier they've intentionally held back from public release due to its capabilities, right?
Exactly. They are basically using Opus 4.7 to battle test their new cybersecurity safeguards in the wild. Opus 4.7 includes deep internal classifiers that automatically detect, flag, and block requests that indicate high-risk cyber activity or unauthorized system access.
So it's actively monitoring its own behavior.
Yes. During the training phase, they actually experimented with purposefully degrading its offensive cyber capabilities while maintaining its defensive coding skills. So the entire release of Opus 4.7 is designed to observe how these autonomous guardrails hold up against real-world use before they even consider deploying the Mythos class models.
So it's a highly capable agent, but it operates inside a reinforced digital cage. That makes sense. Let's pivot to one last behavioral quirk, though, because this extreme capability changes the fundamental way we communicate with the machine.
Oh, you mean the prompting shift?
Yeah. We talked about how it doesn't fall for dissonant data traps, but the release notes imply that our daily prompting habits might actually be a liability now.
This is honestly one of the most counterintuitive aspects of the 4.7 release. The model is so advanced at following instructions literally that your old, reliable prompts might completely break your workflow today.
Break it because the AI is being too literal. What is the actual mechanism behind that?
Well, older LLMs utilized a somewhat loose attention mechanism. Developers got used to writing sloppy prompts, throwing in contradictory instructions, massive blocks of irrelevant context, or weird emotional pleas. And the model would just statistically guess your true intent and gloss over the messy parts.
Right. It would just kind of figure out what you meant, even if you phrased it terribly.
Exactly. But Opus 4.7 applies a strict literal attention weight to your input. It assumes that if you typed an instruction, you meant it definitively.
It's the ultimate form of malicious compliance, basically, except it isn't trying to be difficult. It's just operating with total literal precision. So if I give it a messy, contradictory prompt, it is going to execute a messy, contradictory workflow.
Right. Anthropic has explicitly warned users to retune their system prompts and testing harnesses. You can no longer rely on the AI's internal ambiguity to smooth over your sloppy directions. It demands clear, unambiguous logic now.
Wow. Okay, so what does this all mean for our listeners who are logging into their dashboards today? Let's distill the practical takeaways from the Opus 4.7 launch. First, the ecosystem has definitively crossed the threshold into AI autonomy. The tools are independent agents now. Your role is shifting from the creator of the initial syntax to the orchestrator and reviewer of autonomous digital workers.
Second, you must audit your task budgets. The new tokenizer maps to more tokens per query, and the deep reasoning of the X high effort level will consume output tokens way faster.
Even if the net efficiency is higher because you avoid those infinite retry loops, the upfront cost per interaction will definitely look different on your billing page.
Exactly. And third, you need to ruthlessly edit your prompt library. You are interacting with an entity that takes every single word at face value now.
It really forces the human operator to become a much clearer thinker.
It absolutely does.
Which brings me to the final thought we want to leave you with today. Anthropic's note about Opus 4.7 following instructions perfectly means that the era of the AI whisperer is essentially over.
It really is.
I mean, we've spent the last 3 years developing these bizarre psychological hacks, telling the AI to take a deep breath or offering it a fake $20 tip to write better code. But as these autonomous models get smarter, and as they start actively pushing back on our bad architectures like a highly opinionated colleague, will the true skill of the next decade be unlearning all of those weird algorithmic hacks and simply learning how to communicate like a clear, decisive, and effective manager? It's a great question. If you are going to orchestrate a fleet of highly capable digital workers, your absolute first requirement is to be a competent boss.
Something to think about while you rewrite your system prompts this weekend. Thank you so much for joining us for this News of the Week deep dive into the evolving AI landscape. We will catch you on the next one.